Alex is coming at us from ZenML. Where you at, Alex? There he is. Hey.
Hey, how's it going?
I'm great, man. How you doing?
I'm good. I'm good.
Well, I know you got a presentation for us. I also am here just to keep us on time, keep everything going smoothly. So I'm going to share your screen, bring it to the stage right now, and then we'll get rocking and rolling. Actually, no, you don't even have a present. You took the bold route, didn't you?
Just going full live demo today.
Oh, all right. Everybody, pray to the demo gods. This works. I'll leave you to it, Alex. Thanks, man.
Thanks, Demetrios. Hey everyone, thanks for coming. Definitely been a great bunch of talks that I've seen so far, and a bunch on this kind of theme of like getting from like experimentation, working as a data scientist, and so on, and getting things into production. So that's what I wanted to talk about. Talk about ZenML. ZenML is an open source framework and tool that allows people to work within teams and get their machine learning workflows into production. We integrate with a whole bunch of different tools, 50 or more actually out of the box, fully customizable. You can run your workflows or whatever on all the major clouds. All of this kind of thing is taken as a given, and orchestration is kind of at the heart of what ZenML is doing. We allow you to kind of make your pipelines reproducible across your organization and within your team. So this allows you to kind of iterate quickly, to track everything that you're doing so that you can kind of rewind and go back to a previous run or whatever it was you were doing 2 weeks ago that your boss suddenly needs to see, and kind of minimizing the costs of like switching stacks and so on. But what I wanted to talk about today is kind of a recently improved feature of like doing work within notebooks. And so I'll talk a little bit about kind of just some kind of high-level ZenML concepts to start with, and then we'll get into an actual GenAI use case. So with ZenML, you have stacks, and stacks are basically a kind of a collection of your tools and components that you have. And you start out with, obviously the local one, and this just runs on your local machine, wherever it is. So you can have a bunch of steps, and steps make up your pipeline, and you can kind of compose those steps, which are basically just Python functions, as you can see on the screen. Running them is pretty easily, and you kind of put them together in a pipeline. But let's say you have something a little bit more kind of involved, and you actually wanted to run it on a GPU or run it on a really powerful machine with a lot of storage or memory or so on. You can just switch stacks. So we have a CLI command for this. You can also do it from within the notebook, as I do here. And so I have a kind of Kubernetes stack set up with a powerful GPU machine, and we can just run run the same pipeline on a Kubernetes stack. And that all happens really quickly. I just ran it just ahead of this presentation, but I promise you that happens in, well, look, we can see how long it took. It took 1 minute, 23 seconds, so pretty fast to run. But what I want to talk about today is a little GenAI example, just to show how you can kind of experiment and iterate through a notebook and to do something that could then kind of get you going into production. And for all machine learning, we have to do a little bit of annotation. So we're going to do some live annotation within our notebook. So I have 2 cats. One of them is called Bloopers. This is Bloopers. This is Aria. And we're just going to annotate some data because I only want the pictures of Bloopers, actually. So we need to separate out our photos. This is a kind of notionally simplistic data annotation that we're doing, but I'm just kind of proving the point. ZenML annotates. ZenML integrates with a whole bunch of different annotation platforms and tools. And so this is just one which happens to work within a notebook. And there. We've done a bunch of images. We can save the labels, and these will show up in our little annotations folder here. And then I actually want to just like separate out the photos. So if we just look at these annotations, it's just a JSON file really with a bunch of strings pairing them up. But you can obviously have more complicated annotation workflows. And then we'll just move those particular Bloopers images into their own folder. And then what I actually want to do is I want to augment these a little bit, because for my Dream Booth like Flux model fine tuning, I don't have quite enough images, so I'm just going to do a few things here. I'm going to add some random brightness, some noise, sharpen it a little bit, and so on. This is just to kind of augment our data. And then we're going to use the ZenML step. We're going to copy these images into the cloud. And ZenML, I can show you here on the dashboard. In a second, it's going to start up a pipeline. Yeah, so the copy images ran here, and this is just all of our images are versioned and so on, and so we can use them in our actual pipeline. And now we did all of that locally. Now I want to do something in the cloud because even though I have a powerful GPU machine sitting next to me, it's not quite powerful enough to do some kind of actual fine tuning of Flux. The Flux model is pretty big. This Flux Dev monster, and we do actually have some code here. This code, it looks a bit kind of long and gnarly, but it's just kind of stuff that we copied from the diffusers library. They have a bunch of really neat examples. I definitely would encourage you to check them out. And this stuff could live in your notebook. I actually pulled it out into a separate train.py file for convenience. And you can see here, I just import that here, but you can just shove it in your notebook as well. That's all fine. It's more for convenience that I've pulled that out. And then we're going to actually run this pipeline. It's actually running in Kubernetes right now. So you can see here, if we go to our runs, it's actually downloading the code and so on from ZenML. ZenML is kind of versioning all of the code underneath the hood, as well as all of the artifacts and things that you're working on. Here it showed up, our train model. And so here you can see the stack that it's running on. You have the specific code that was used for this run. This is all versioned and tracked. You can view the logs. You can see any configuration. You can see the pip packages which are used, as well as kind of any outputs and things. This pipeline doesn't actually output anything, and actually it's completed its run. You see, it's a bit smart. It's using a cached version of the model. If I were to change any of this code, it would realize that we needed to kind of unlock that caching and actually do it properly. But yeah, I realized we didn't want to stand here for half an hour as this trains, even though we have a fast machine. And actually set up kind of Dreambooth training with Stable Diffusion as well to have something to compare it to. I already ran this earlier. We don't need to run this, but that's here sitting in the Dreambooth pipeline SD, similar kind of thing. And once these are done, we've got this. We had it automatically push the models to Hugging Face to the hub. This is convenient. A lot of people use this as a kind of de facto model registry, and both of these models, you can run inference here actually within Hugging Face. But what I want to do is actually kind of get a sense of how well these models did on their own. So I'm just going to set this working again on our Kubernetes instance, and it's going to do a bunch of inference to see how well my model has trained with these few images of my cat. And we've got important extra images of Blupus sitting on a laptop keyboard and Blupus in a data center. These are photos that I'll probably never be able to take. So it's important that we capture them. It's important that we capture the prompts as well as the images that come out. So this is all running again on my Kubernetes instance. We can check this back out in the ZenML dashboards. And yeah, here we have the inference pipeline. Again, we ran this before, so it's going to just use the cached version. So I can just take a look at a previously ran version to check this out. And we can look at the output, actually. So this visualization gets a bunch of these images all together. And this is all from within the ZenML dashboard. And you can see here, Blupus in the data center, Blupus, I think, in the server room, Blupus around my Blupus wearing some VR goggles. Yeah, all important images. Nice work, Flux. And again, if we wanted to switch to run these locally, we can just run them here within our pipeline. From the notebook, from within our local system. And this is the Stable Diffusion model. As you can see, it's not quite as good as Flux. Flux is the latest thing. It's not quite capturing what he looks like, but it's done an okay job. And of course, we can do the same with Flux. Yeah. And I just realized that Flux is going to actually crash because we're going to run out of memory. So just run Flux. And all of these hyperparameters and so on. If we wanted to capture all of this as well as the prompts, we could just again run it in a ZenML pipeline, farm it off into to Kubernetes, and have it run there. I think we ran out of classic CUDA ran out of memory error. Yeah, there we go. And this is going to run again in a second, and we're going to get the Flux model, which kind of did it properly. And you can see the kind of the convenience of like switching between something which is within a notebook, classic things that data scientists are happy and comfortable working with. And you have this kind of experimental feel to it, but it's actually, you get the benefits of kind of being in production and having, this is again, Blupus in the data center. So you kind of have this, with the dashboard and all of the things that ZenML is supporting doing behind under the hood. You're kind of getting the benefits of a production system. And this is really pleasant for both data scientists as well as perhaps ML engineers or an ML platform team who want to support you. And as I hope I kind of showed, it's basically kind of just you're writing normal Python. If you wanted to switch from running this on Kubernetes and you actually wanted to run it on Vertex, you wouldn't need to change any of your code. You would just need to switch stack. So yeah, that's kind of what I wanted to talk about today. I hope you enjoyed a little quick fine-tuning of everyone's favorite model these days. Please do check out ZenML. We're an open source library. Check us out on GitHub. Go to zenml.io if you want to kind of get a high-level overview of what we're doing. And we'd love to see you in Slack training your own Flux models and so on.
Excellent. So I think the key takeaway here, it was that, because some people were asking in the chat, all right, cool, notebooks, fun, but not production, right? But I think the thing you're saying is you just swap them out really easily from notebooks to something more production grade.
Yeah, and I think the thing is, it's not necessarily something that we encourage people to like only live in a notebook, but it's pretty easy. Like once you've designed your code and stuff within a notebook, it's pretty easy to pull stuff out then into like normal Python modules. But it's just like allow people to do things where they're comfortable, and then you can, get to production easily.
Excellent. Well, if anyone else has more questions for you, Alex, I encourage them to reach out and talk with you in either the MLOps community Slack or in the ZenML Slack. That's really cool. I'm super happy for you all, and I look forward to more fun stuff. But for now, we're going to keep it moving.